calling the meeting to order. Okay. Meeting is in order. Open forum for any non-agenda items. Anybody online that wish to bring up anything, please do so.
Nobody is attending online and no one's here, so we can proceed.
Okay. Approval of the action minutes, October 22nd, October 22, and February 23. Any corrections, additions?
I move to approve the October 22 and February 23 minutes.
Second.
All in favor?
Aye.
Okay. Discussion items. Storm drain master plan.
Okay. So yeah, today, we've given some small updates on the storm drain master plan over the last year, but tonight we're going to go a little more in depth and just talk about what's already been done, where we're at now, and what we have to do in the future. So I'm going to pass it off to Robin with Shop and Wheeler, and she's going to talk about the project.
All right, good evening. I am Robin Lee. I'm the Senior Project Manager at Shop and Wheeler and the Project Manager on the Master Plan update. So I want to go to the next slide. I'm here basically to talk about what we've already completed and then the work that's underway currently right now, and then what we have in the future. And so far work completed. We started, the next slide.
Okay.
With actually a king tide visit, which was really fascinating. And I'm sure all of you know kind of where we went. I'll show the pictures on the next slide. And then we were provided the town's storm drain inventory, both in AutoCAD and GIS. And we have a sub-consultant firm who is rectifying and kind of bringing those all into one database, so that that can go into the town's asset management. And so that's kind of the ongoing work as well. But then with that consolidated GIS, and the GIS is the platform that we're really working with right now, because that's where all your hydraulic models interface with, and that's also what your asset management software is going to interface with. So we basically were bringing all the data and information that is historically kind of in AutoCAD drawings, and then bringing them into GIS so that we can kind of put them into our asset management. We can also put them into our hydraulic models. So then we went out in the field with our Survey 123, which is a collection app that interfaces with the GIS. We're updating the attributes. We're taking pictures of the pipe with a full mounted GoPro to kind of assess the condition of the structures. So next slide here. So this is our king tide visit, which was obviously fascinating. You can see, unfortunately, there's a screen on the top right there, but that's our map of all the pictures, which I'm sure these are the places that everyone knows, where you basically just have low-lying area and the tide coming in. So absolutely no rain, although it doesn't look like a very cloudy day. There was no precipitation, just the tide elevation coming through. And so next slide. And so this is our field crew with a GoPro on a long pole, taking pictures of the inside of the pipe, and I'll show those pictures too. We also looked at the culverts along Paradise Drive and did a cursory capacity analysis so that we could kind of get those ahead of the Paradise Drive project, because at that time we didn't have the whole hydraulic model built. So, next one. This is a quick summary of the condition assessment that was done on the pipe. So we have a NASCO certified, that's the National Association of Sanitary Sewer Companies. They have a sort of set standard for reviewing pipes, and you have all of these different types of defects, cracking, inverts, offset joints, and they all go into sort of a rating and have a scale of 1 to 5, 1 being excellent and 5 being needs attention, 4 being poor. And so here's a snapshot of the condition assessment. Now, there are a lot of projects ongoing at the same time, so I should side note that Shop Wheeler is also doing the Madera Gardens sewer and storm drain project, which also had a collection of CCTV, which we haven't integrated yet into our master database. But one issue that we are running into in the field is pipes being submerged. And even though we planned to do this at the lagoon lowering during the summer when they're lowered beyond what the normal lowering is so that folks can work on their docks, we're still running into pipes that are submerged. So when the pipe is submerged, we can't actually get a really good picture. And it does bring up an issue that Chris and I have been talking about. We'd like to do some CCTV. That's when you actually have a camera that travels the entire length of the pipe. But if the pipe has water in it, those whatever rovers can only make it through a certain depth, which is usually 3 or 4 inches. And beyond that, they can't make it through and get a clear picture. So in the Madera Gardens, I was looking at that data the other day, about 30% or so of the system was able to be televised. And of that 30%, about 80% of the system was in relatively good condition and about 20% needed some sort of cleaning, maintenance, or repair project on the storm drain pipes. So this is a map, and unfortunately, probably very, very small lines, and green was probably not the best color, but this does show, this was actually created for the town. It's in a very high resolution so that Chris can kind of actually zoom all the way in and really get close and see the street names, basically to mimic having a GIS map, but in a PDF format. And then we've color coded the pipes, green being that the pipes are in good condition and the red being pipes that needed attention. Next slide. So here's the condition findings, and of course I'm showing you the worst because those are the most interesting photos. We did get a lot of photos of reinforced concrete pipes that looked in good condition, but we've got failed liners, eroded inverts, some cracking, and then on the far right hand side you'll see what I was talking about with the submerged pipe. So unfortunately, it's challenging to actually get a picture of the. And then I believe, Robert, did you meet me in the field the day we were flying this drone? That's right. Okay. Yeah. We had a lagoon survey done. So this is a picture of the drone that goes out and then basically like a lawnmower goes back and forth collecting imagery. And then these are all put together and then we're provided with surfaces. So if you go to the next page, I can kind of show you what these 3D surfaces look like. And these were done again during the summer lagoon lowering. So unfortunately, all of the lagoons still have water in them. They're never lowered all the way down to silt. And I think that's based on the environmental regulations that there's a minimum water needed. And so what we're using in our model is basically, if you think about it, there's a bit of dead storage in the lagoon, which is that water that's there. You can't lower any more below. And then what we're using is we're creating stage storage. So that's basically incremental feet above this dead storage into your volumetric detention that you can achieve in each lagoon. So we were able to take these surfaces in CAD and create these stage storage curves that are then put into our hydraulic model. All right. We also had some survey. We have a sub-consultant, Kieran Wright, who did some surveying at key locations. These were basically provided to the town so that they can better understand the elevation, mostly around pump stations and gates. And if in the future you wanted to install a tide gate or a tide gauge, these elevations are tied into benchmarks so that those can be installed in the future. And you can see a picture actually on the right of our survey crew out there. All right, so I also have Ben Schick on the Zoom call today. He is the lead engineer on the pump station and the gate condition assessment. And so this is basically what we, completed so far. We've gone to 10 pump stations and 3 gates. We've looked at all the historical records, which is quite a library that Chris sent to us, maybe the entire library. And then we came up with some preliminary recommendations and estimates to either replace the equipment or rehab the equipment. And Ben is currently working on a draft assessment report. So when we get to the end, if there's more detailed questions, pumps and gates, Ben can answer those. And then there's still work to be completed, which is confirming the capacity deficiencies with our hydraulic model. So they kind of go hand in hand. Ben has been working on developing the system curves, which we then put into our hydraulic model. And then we'll go back and forth to see, when we're developing the capital improvement projects, if there's a capacity deficiency. And they're also working on a cathodic protection assessment. Great. I don't know why this slide is different.
Yeah.
Well, they're all different.
Physically awesome.
That's fine. So the high level summary of the pump station and gate condition assessment is that the equipment is on average about 30 years old. And our typical life expectancy of pump station equipment is about 25 years. So in a sense, kind of on borrowed time right now. The typical deficiencies are lack of redundancy, basically the age, corrosion, of course, because we're in a saline or brackish or salty environment. And then there's also safety and code related. So I think the next slide, we have kind of a summary. Oh, no, these are just some pictures. So this is basically out at the Shorebird Marsh pump station, a couple pictures. And next slide. This is Lagoon 1 pump station, 37 years old, significant corrosion. Next. And so here's the table of the recommended improvements. And it's a lot to swallow, of course. These numbers are in the millions. There are 2 columns though. One is a short term, which is if you want to do sort of immediate repairs to extend that 25-year life expectancy. And then the full station gate rehab would be if you want to go ahead and do a full rehab. So you would not do both columns. If you're intending to do a full rehab, you would not have that short-term, the short-term improvements, or if you are not wanting to take on the full station rehab at the moment or in the near future. Yes.
So Robin, in relationship to the pump stations, are you also looking at, are these needed? Are all of these needed? And are they needed to the degree that they were originally created? Thinking of Lagoon 1, I think that has a lot of pumps because that was done before the High Canal pump station went in, which has taken the load off those. The Marquardt Lagoon just has a very small pump, as I recall, to clear that. And, the big G, I've looked at that as something that potentially could be done away with.
Right. Yes.
So,
That's a
are you
great
looking
question.
at those things too?
Yeah, and Ben and I were just talking about this the other day that, with the hydraulic model, we would have the ability to turn the pumps off, which in a sense would simulate, catastrophic failure. What would happen if you had, say, a high tide and a large storm event and the pump didn't work? But I think one of the challenges is that a lot of these pump stations are used to basically drain the lagoons. So there's a lot of different scenarios to look at. For instance, if you have a storm event on a low tide, you're able to drain at gravity. But let's say you had a storm event and then you had a high tide and then you had another storm event. You haven't had that ability to drain by gravity on the low tide cycle. And you're right, with the high canal, you can actually drain the high canal. But we would want to look to make sure that that high canal pump station can fully drain so that your lagoons can also drain by traffic.
Right, so the tide wouldn't be as important as long as the High Canal pump station was
Operational.
functional. Yeah,
Right, and then that kind of goes back to the redundancy, so maybe there's a scenario where you add a lot more redundancy to the High Canal, and then you don't need to worry as much about the lagoon pump stations.
that makes sense.
We will definitely, we will have the ability to do that.
Robin, RJ Seeker here. I just want to jump in, make one comment before we leave this slide, and that's we're in the process of advertising and bidding the San Clemente pump station work. So, that's scheduled to proceed this upcoming fiscal year. So of that 3.39, we've kind of already accounted for that project.
And I will say with that, are running different scenarios on the San Clemente pump station in regards to the Big G and whether or not it is needed. Because you're right, it is connected as well to San Clemente.
Yeah, now that the culvert and the tide gate has been closed, underneath the Paradise, and all of that drains through the San Clemente pump station, it would seem like, that's superfluous at this point.
Yeah, and it looks like on the Big G, we don't have any near term. Well, if that's a relatively newer pump station.
Yeah, and I just want to mention the San Clemente floodgate is now fixed, so that usually drains those canals in the summer when the pump station isn't running. It has a transducer that opens when the tide's low, lets the water out, and then when the tide comes up, it closes it, so it's automatically running now.
Oh, okay.
Yeah.
Okay. That's funny. Okay, so now we're going to move into the work underway. So we are developing the hydraulic model, and because of the San Clemente pump station project, we did a sort of focus. We built the entire hydraulic model, but we focused on debugging, validating, and calibrating the San Clemente area so that we could get appropriate flows for that design, and especially for the summer dewatering needs. We're looking at 3 main storm events, the 25-year being the design of the system, but we use the 10-year as well to debug the model as well. So we're looking for areas that are flooding during the 10-year that we don't think should be flooding, and then we're finding issues in the model. And some of these are just inconsistencies with diameters of pipes. So we'll have a large pipe coming in, a small pipe, and then a large pipe again. And so we have a laundry list of areas that we need to go field verify or look to as-built to confirm whether or not there truly is a small stick of pipe, or if it's just that the diameter was added incorrectly. And with the ultimate goal that we're building capital improvement projects to the 25-year, and then we're looking at climate change on top of those. So precipitation changes and of course, sea level rise. So this is the model here, and our focus is the pipes that are 18 inches and larger, that being really the trunk line, the major conveyance, areas where you have the most impact if you were to have a failure or a conveyance limitation. And so the blue lines are the model, and the black lines are the smaller pipes that are not included in the model, but the drainage to those small pipes is included. It is conveyed to the larger pipes. So we are modeling the entire watershed area, all of the runoff that comes through the pipe system, it's just not necessarily all of those smaller little pipes. Yeah.
Really quick, this area here, which I'm familiar with, I live here, they did a recent improvement project here where they ran storm drainage up the street here at Pacific Queen, connecting to Golden Pine. That was maybe 2-3 years ago. So
Yeah, and I
now
think
have
we
storm
looked at
drainage
that,
here.
and I think those pipes are smaller, right? I'm not sure why they're not in black there, but the area that is draining to those larger pipes is still within the model.
Yeah.
But we'll take a look at it. Yeah.
Think about the slot drains.
Well, they did slot drains here, but on Civic Queen, we chose not to do slot drains. We just did drainage up and down the road. And then
What was the street name?
the Civic Queen passage.
Okay.
I think those were all.
It was a pilot program.
Yeah. Yeah, those may just need to be added to the GIS. I don't know if they're showing.
And the next slide will show the catchments and then you'll see.
And
So
before you
all
move
the-
on from that figure, were those blue lines offshore? Are there pipes that are offshore?
Great question, sorry. Those are what we use for the boundary condition.
Okay.
So that's where we're gonna be simulating a tide or the level in the creek.
Okay.
And then here are our catchments of the drainage areas. So basically what the model is doing is it's running rainfall on all of these smaller catchments, which then generates a runoff, which is flow that then gets dumped into a node and then into the pipes. Very oversimplified.
And the pump stations are also captured.
Correct, yes, the pump stations and the lagoon. So remember I discussed those stage storage. So actually the next slide will show the whole model setup. Here you go. So now you can see the big tanks. Those are basically the storages of the lagoons. And then associated with those, unfortunately, I believe those icons are on top, but there is a pump station icon there as well. So it's a complex system. And we are still working on what we would call sort of debugging, validating. And one of the areas that's challenging is when any time a pipe kind of goes into an open drainage conveyance, because we don't have necessarily a diameter and a depth and an invert like we do when we have the closed conduit system. So there are a couple areas, especially where we got open drainage through the Caltrans clover leaves, that we need to define those channels better. And then a lot of these red dots are going to go away. But if you go to the next slide, I'll show you one of the sort of we're creating a list. This is more just to show that there are areas of unknowns that we're going to go back out to the field. If you go to the next one, it'll show you kind of a profile of what this looks like. So basically pipes obviously running from left to right, and you can see the brownish line is the pipe, and then it comes in where that yellow highlight is a small pipe, and then back to a big pipe. So that's where we're pretty confident that that's an error in the GIS. But we need to field verify. All right, next slide. So this is basically what I've just described, that, you know, we're looking at where we're seeing some flooding issues that we don't think are real. Chris has, you know, in the beginning of the project, we walked around and we visited the problem areas, so we kind of know where we should anticipate seeing sort of ponding. And we also have some, you know, boundaries where Corte Madera flows to Larkspur. So we're going to kind of take a look at those and how do we set a boundary condition line of what their type fullness is, so that our model is taking that into account. And so these are basically, this is what we're working on right now in the hydraulic model. Next slide.
I have a question. So you're really focusing on the closed pipe systems for the most part, as opposed to like when, you know, the tide comes up and it comes in and inundates the roadway.
Well, we are going to do 2 focus studies, and I will get to that as well, but we are going to look at low-lying areas. But to answer your question, yes, we're looking at closed conduits primarily in a 1D, which is one-dimensional. But we are scoped to look at 2-dimensional in low-lying areas like Marina Village and then the Mariner Cove neighborhoods. And so we also have Miller Pacific, which is a geotechnical firm, to help update the experienced settlement and predicted future settlement of the Bay mud. And so they've provided us with this map is actually a contour map of the depths of the Bay mud. So this came from the 2006 study. And you can see there's a lot of black survey points where they'll have 2 different elevations. So we also have in our scope to go out and survey those points again. So we have a 3rd point of reference on these survey points.
And did you guys go back and analyze the reports where those survey points were first recorded? Because I've looked at that and I wouldn't say that I could duplicate their work based on what's in the report. There's nothing about, it's just not a complete survey report. And I've always questioned if we trust the accuracy of those. I'm not sure.
We did not, but I could certainly ask our surveyor to take a look at that before they go out, because I did notice that some of these areas where we've seen significant settlement, they don't show up in these numbers as much. But then again, these are from 2016, so, I mean, sorry, 2006.
Yeah, they might very well have been properly surveyed. I just don't think it was properly documented. So it would be interesting to look and see if you think they're accurate.
Okay.
Yeah, so Robin, I think there were also studies and core samples probably done in the 80s or 90s.
Yeah.
They actually did the core samples to try to determine what's the future rate of settlement.
Yeah, and there's certain icon, I can't read the legend from here, that actually shows where they did borings. We do not have any borings associated in our current scope, but I think Miller Pacific has quite a depth of information to be able to make those predictions.
And those predictions were made a long time ago. And then we have, especially after you do your work, you'll have more survey data. So it would be good to fact check that old work and see
Right, I mean,
if those models they had for mud compression are accurate, because those are, I know it's used in geotech, but I think there's probably a lot of wiggle room on what really happens out there.
there's a table, and it might be on the next slide, that ideally, I don't think I included, but there's basically a table in the 2006 report that had, experienced settlement and predicted future
Right.
settlement. And that their scope is to go back and revise, look at those numbers and update.
That's Miller Pacific, that's what we do.
Yes. And but Miller Pacific is not surveying. There's no warning. That's correct. And Kieran Wright is the survey firm, so they'll work together.
The other thing I was going to mention is really the GPS surveys, I think, have become a newer technology, post 2006. And so it enables us to much more efficiently get survey points that we can trust and believe in, although they have a tolerance level that, maybe Robin or Ben could speak to. Whereas the older surveys could and would likely have, unless they spent a lot of money and time, would have relied on kind of previous records or previous surveys done by other people, as opposed to relying on the GPS network, which is, I would say, more accurate, but less precise.
And RJ, you might recall, I think I sent you and maybe Chris some information a while back about, I think it's a university professor who has access to this huge LiDAR database, including historic information. And if it's within the budget, I can resend it, but there's the possibility to look at multiple years in the past and have an entire neighborhood down to the centimeter, basically. So it would be a good way to verify current rates of sinking. I can resend it, but if it's out of the budget, it's out of the budget. But
Yeah, it would be interesting to take a look at that, because Marin County flew their own LiDAR in 2019.
yeah,
And so my fear always with very large data sets is that you get accuracy, but we could, if they had anything in 2019 and we find that date of the Marin County LiDAR and spot check it, we can kind of verify whether we believe that it's accurate. So we'll have the 2006, which are on here. We have the 2019, which is LiDAR, and then we'll have 2023. And then we can take a look and kind of compare where those fall.
I think we mentioned this, Bob. I have a faint recollection that we were talking about how the building department's going to amass a whole lot of boring data from residential projects that have to get geotechnical reports done to build in this neighborhood in particular. So I don't know what the
I
problems.
think Miller Pacific will have those. I mean, I think their scope of and why they didn't put borings in it is because they have quite a huge database.
Oh, okay.
Okay, next slide. All right, so we have SKL Solutions. They are a sub-consultant who is also working on compiling all the asset management, so the GIS database, inventory maps, putting in the inspection data, and then, you know, ideally, the storm drain system inspections and cleaning is tracked such as the sewer pipes are. So right now, the asset management software is primarily used for the sewer pipes. And the goal is to get the storm drain system in there so that it can also be used in the asset management software. And so future work, I've alluded to a lot of this, but based on coming up with these capital improvement projects based on the hydraulic model. So we would have capacity relating, the pump stations, maintenance as it relates to the waste conduits, inspections. And then then we're going to take a deeper dive into these two low-lying neighborhoods, which are basically divided by the creek. So we have Marina Village and Mariner Cove. And this is where I was saying we will be looking more at a two-dimensional model, because this is the area here where upsizing a pipe might not necessarily be the CIP that you need, because if you're getting inundated by the bay, a larger pipe's not going to help you. So we are going to take a little bit further look in this low-lying areas. And then this is the 2019 Marin County LiDAR, and it really shows the areas that are in blue are actually mapped below elevation 8. And I think when we get king tides, they're anywhere between a 7 to 8 on the highest end. And so you can see where water is kind of coming into these neighborhoods on the fringes that are as shown in blue. And then the green are the areas that are 8 to 10. This is the table that Miller Pacific will be updating. That kind of gives you the settlement seen thus far and then updates the estimated future settlement. So next. And then finally, on top of all of this, we don't intend to study sea level rise or come up with new predictions, but more coordinate with the county efforts. So the county has their bay wave scenarios, and they have different estimates for near, mid, and long term. So these are sea level rise needs to be considered on the capital improvement projects that are in the low-lying areas. And then in the upper watershed, we would want to look at precipitation changes. In general, from a couple of the past plans that I've done, we've put on something like a factor of 0.4 onto precipitation, a 40% increase on precipitation, and then we run it to make sure that the capital improvement project that we conceptually designed can withstand precipitation increases, or if it needs to be upsized, then we would make that recommendation. All right, next. And then this comes from the sea level rise vulnerability assessment, again, also done by the county. We don't anticipate redoing any of this, but you will notice that on the right-hand side, there's kind of 6 focus areas. And I know that the town is already working on Paradise Drive. And then we are looking at 2 of the neighborhoods in here. And then Ben is currently working on the yellow, which is the Madeira Gardens area, both storm and sewer pipes. So the town obviously has a lot of low-lying areas, but a lot of them are being looked at. It's not going to be obviously an easy project or a short-term project. This is more of the long-term. And so from there, I think that's the end. I'll open it up for questions.
Yeah, I was going to just make one further comment and try to provide a little more discussion around how we're going to tie the climate adaptation assessment in with the work that Schaffenweiler is doing. Obviously, there was, several years worth of work on the climate adaptation assessment, looking at sea level rise and potential for flood barriers. And so the missing piece that really we wanted to spend our money and focus on was the kind of internal storm drain network, and kind of assuming that along the kind of bay fronts that we would, establish some solutions and kind of work toward that, but also find a way to tie them in. And so even just based on some of the work that we've seen from Schaffenweiler, we've budgeted $200,000 to further the design work on the Marina Village berm. And you might be saying, why am I using the word berm? But it's not a FEMA accredited levee. So technically we aren't supposed to use that word levee, although I know it's been used historically in the past by previous studies and whatnot. But we do want to further look at that in this upcoming fiscal year, and definitely make some headway on kind of opportunities and solutions on that. And then as we kind of look down the horizon of other areas of kind of higher priority vulnerabilities, we'll also do the same.
I had a question of the model. And I'm not quite sure if it's feasible, but are you capturing in any extent the sheeting water from the mountain hillsides down into Mariner Cove neighborhood, just any both side runoff coming down on the surface? Because we're doing rain, we're doing sea level rise, but.
That's a great question. In theory, in a one-dimensional model, you have basically a flow input to the node, and then if it's ponding, it's flooding at that node. But with one-dimensional, you don't really have that flow then going on top of the surface. But we do have scoped to look at those areas in more detail. So I'd have to think about how we would, without exploding to the entire system being 2D, how we can kind of account for that. And so you're thinking of the water that's sheeting over Paradise Drive and then kind of
Coming down the storm drain system, which I'm not sure if you guys have seen that. Large sheet water coming across Paradise into Mariner Cove.
I haven't seen
I
that.
don't think I have, just the gravity makes sense, so I don't know if it happens.
Yeah, I mean, because I live at the Cove School side of things, right? So there's an offset between street as it comes down, right? And so everything on, for a pretty good length of Paradise between Golden Hind and whatever that street is, up there, Winter, it's just hillside. So most of that's not gonna, it's just be saturated. You might get flow, but it's not gonna be the sheet flow that you see. You might see it maybe at over by but that's a storm drain pipe right by Aegis.
Yeah.
Right, so I don't think there's that much opportunity for it. There's a couple, like there's the church, they go to the Hilltop Church, I think, right? There's a street that comes down there, but it's, I'm guessing that a lot of that's captured somehow and conveyed across, right? So I don't think it's a huge risk. I mean, you could look at the elevation of Paradise itself to the ceiling, I think, because I don't know that I've seen climbing, for example, in that segment on the south side of Paradise.
Yeah, I don't know if I've seen it sheet water across Paradise. I thought maybe all that water's coming down the hill somehow.
I mean, ideally, we're looking at the upper watersheds again, when the nodes are flooding, we're sizing a pipe to capture that flow. So that you, in a 25-year storm event, that flow is conveyed underground through pipes.
Right, because you'll see it coming down the street up in Denver, right? You'll see it coming up and it's going down the curb, goes in the drop inlet, then it goes into a pipe. And then the next segment of road also has curb going into another drop inlet. So I think most of the roadways go into a closed pipe system. That's one kind of my observation.
Yeah, and if I could add to that, so just to give a little more clarification. So for instance, you may all be aware, or I know you're aware of our Paradise Drive Complete Streets project, which is, east of Westward Drive. And so through standard basic modeling, they take the area, they use some kind of standardized saturation rates and various things to account for that water that lands on, say, open space, and then eventually goes to the pipe. And so they were able to give us some fairly confident answers that our current pipes on that stretch of roadway are actually appropriately sized. And so really the risk here is only if you're taking, and I think you said it, I just wanted to make sure it's understood because it's slightly different, that the water is actually sheeting across a hardscape and entering into another, storm drain collection zone. And that's where the model would be troublesome.
So will we have the ability, I know you talked about the 10 and 25-year design tests that you're doing with the model. Will we have the ability after we get report out to Chris and RJ to continue to use them to tweak the model and try other scenarios?
The model that we're running right now is in what's called a Mike Plus platform, and that is a proprietary software. But we would have the ability to export to, say, SWIM, which is an EPA-free software. It doesn't have all of the capabilities, but you would have sort of a tool that you could use if you wanted to.
Okay. This is a great foundation for the storm drain work, but also that feeds into what we might do in the future to protect against sea level rise. And it's like a 4-dimensional game with sea level rise, storm recurrence intervals, potential for changes in rainfall long-term, and then subsidence. And if you add all those things together and look at a worst case scenario, or it's going to end up requiring enormous engineering. And I just think it would be very useful to not be trapped by those numbers. Like the sea level rise scenario you had for 2100, I think that's the 1 in 200 chance of being exceeded. So very unlikely. And then you used 100-year for the rain, and then a 40% increase in rain long-term. And I've seen no evidence that rainfall is increasing at all. So all these things are adding up to an enormous system that might be overbuilt. And I just think we're going to have to make some real decisions in town and probably scale back from some of those huge numbers.
Yeah, and that's again why we're looking at prioritization, because we would never put a high priority project that is based on 40% increase in precipitation.
Right.
A high priority project would be something more like, and I've talked to our modeler too, is let's run a free open boundary condition and see if there are any pipes that are really undersized based on no boundary condition. And then we would have to put those as a much higher priority than, say, something that is getting inundated on a 1 in 100-year chance. The other thing is that when you are modeling these different scenarios, I think you would never put a 100-year tide and a 100-year rainfall happening at the same time. Even the way that FEMA creates their floodplain maps, they're running a 100-year storm in the rivers with a mean high tide. So you never put, I mean, you're right, you're kind of doomsday designing.
Probability gets very small.
Yeah, exactly.
It would be too expensive to build.
Yeah, so we would be prioritizing projects that are immediate needs way in advance of anything that would be a future need.
And then just the last question, I think this is probably for Chris and RJ, is I was surprised that you were modeling to potentially build the system to 25 years. Like, how did you guys decide 25? We've talked so much about 100-year storms or 50-year storms, and we're designing to 25. So I assume if we build out the system to 25, it's gonna be inundated frequently.
Well, I mean, it just comes down to what you were talking about, practicality and cost. A lot of times, I mean, they have different recommendations for what year storm you build, depending on like the location and the risk to surrounding area. But I think 25 years is like a realistic goal. And I mean, even if you get a 100-year storm, it may flood around it, but usually it won't like put anyone at risk. Right? So that's kind of the thing behind it. But
I can add a little bit to that because it's really an interesting question, and there actually is an ongoing. So Marin County doesn't have a drainage manual that Fred, it tells you, well, there is one. We have a scanned copy of it, but it's from very, very long ago. No one uses it. And the design standard was a 25-year. Now, if you look at Alameda County or Santa Clara County, they both have drainage manuals, and the design standard is 10-year for a closed conduit system. But the cities obviously have the option of making that standard whatever they want. So the city of Santa Clara would say a 10-year storm in pipes. However, we want a 100-year storm event in our pump stations. So city of Santa Clara is draining all to sort of Perch Channel. So all of their interior drainage has to be pumped through a levee and then into a creek. And so they want those pump stations designed to 100-year, but the pipes is a 10-year, which on top of those pipes is a roadway, and a roadway acts like a channel. So when we're saying you're designing for the pipes to convey the 25-year storm event, you're not typically inundating structures with those larger storm events. You're conveying it through your streets. But what we're saying is that in a 25-year storm event, we don't want any water ponding on the street. And even a 25-year, I would say is, it's a 4% chance of occurring. So it's a relatively large event to try and then also fit into a pipe. So one of the nice things I think about a hydraulic model is it's an opportunity for you to look at what makes sense for a level of service in the pipes. And I will say we've worked with jurisdictions that they started with, this is what we want in our pipes. And then when they saw the cost, they said, we'll go to here to make it more of a bite-sized capital improvement project. And you can also use that to prioritize, right? Systems that aren't conveying a 10-year, you would put as a high priority. Maybe those that you need, and if there's a lot of those, you tackle those first, and then you start looking at the 25-year.
Yeah, you touched on kind of what I was thinking is you might have different numbers for your conveyance and your pump stations.
Exactly, and that's actually what I was just talking to our modeler about too, is maybe we want to look at a higher level of service around the pump stations for that reason.
Yeah, it's going to get there. Like you said, it
Right.
might be in the streets, but the water's probably going to get to the pump station in a 100-year storm
Yeah.
somehow.
Yeah, and if I could jump in and kind of circle back on a few questions. So I think you're Board Member Blumgren asking about building upon the work that we're doing here, and that's absolutely what we want to do. It may not be using a town staff behind the wheels of a software program. I mean, I just don't think that's likely in the near future, but we certainly could, whether it's Shack Wheeler or, as part of an addendum or as part of, a few years down the road, we want to look at something in more detail. We can use all this work and effort and modeling they've done and then do further analysis. So it's not a one-time only thing. It really just improves our understanding and of the whole system that we just carry forward. The other thing I was gonna say, I don't actually think we've decided on what level to design to. So I think that's just something to be aware of. And I think also the point that Rob made about a 25-year just means that it's all staying within the pipe, but it doesn't necessarily mean that it's flooding. An example of that is, right, we know we had a 100-year storm on October 24th of 21, yet I'm not aware of a catastrophic incident that occurred. I'm not saying that, some garages weren't flooded or maybe someone didn't experience some flooding in their home, but at nothing to the level that we see in those 1983 photos, right? So that's something we're, gonna look at, see what makes sense in terms of, how we establish budgets and priorities and all those things. And then I believe also the previous flood control studies, I think also were a 25-year storm. So there is some kind of consistency with that.
I have just a question / comment, which is, the thing that's changing is, right, intensity of rainfall, right? So if you look at a 25-year event from historic data, and I'm not sure how bad, because I use like the NOAA IDFF, right?
Yep.
When you go around, like, are they adjusting that for more recent rain events so that, what a 25-year storm from 20 years ago, whether that's, if you look at more recent historical data, does that kind of still coincide, or I think it's being updated as they get new data, right?
That's a great question. And we've talked about, taking, say, the peak intensity of a larger storm and kind of dumping it into a hyetograph of a smaller storm to get that higher intensity. However, this past wet season, we saw very little intensity. we saw it rained forever and it never peaked. And if you look at the S curves on the rainfall, instead of this intense peak,
Right.
it is just a flat line. And I think that is a little bit to why a lot of our systems held up relatively well in Marin County. Now, the peninsula was a totally different story and we saw lots of flooding down there. But the intensity was never really peaked in Marin. It was wild. So now we're reassessing of, you know, how do you model these hypothetical changes in rainfall? And the reality is we're doing a very simplistic, just adding more rain. But you're right, there has definitely been reports that have said, oh, it's gonna be more peaky, more intense, less events. And
Right.
that is exactly the opposite. We
What
just
makes
saw.
this experience, yeah, interesting. Yeah.
And even if, oh, sorry, I don't know if I interrupted.
How do you, when you say you're gonna model against 25 or 50 or 100 year storm events, are you actually modeling just overall rainfall over a particular period, or are you looking at what if it dropped 8 inches in and out?
It's a great
Yeah.
question. So the way that we model these events is using a design storm. So we are, in layman's term, we are faking a rainfall event, not something that has occurred, but we are faking a rainfall event so it produces runoff to that statistical event. So we're using creek stream gauges, Arroyo, Corte Madera, Corte Madera Creek, local creeks in Marin County, mainly associated with TAM, so that we're getting the local climate. And we're faking rainfall to produce these stream flows. And that's how we call them a 10-year. Because you can have a 100-year rain and a 10-year runoff in a creek if it's really dry. You can have a 2-year rainfall that's occurred after it rained for 10 days straight, and it could produce a 25-year in a creek. So what we try and do is we come up with hypothetical or a design storm that rain produces what we would anticipate based on statistical. And there is an ongoing work that is being done by county flood control to build this drainage manual, which is a shame because I think it's not going to be written in time to sort of guide our project, but we have done quite a bit of work in similar watersheds, kind of coming up with these design storms. So we do have that.
Yeah, and I think 25-year agree. I mean, I see that often as in county design manuals, it's a pretty conservative design basis, because the challenge with stormwater, right, is that it peaks. And if you designed a 50-year, let's say, you're gonna way oversize your system. So you're only gonna use like 1% of the chance. And so you have this huge capital cost to build something that is only gonna work for you, or you only need that 1% chance. And that's like the trade-off, right, that we all have to kind of really think about. The other comment I would make is I'm really interested about that 2D modeling, because, you know, in most of the low-lying areas, it's the high tide,
Right.
which is the governing factor. The storm drain capacity is immaterial in that.
Exactly.
It's just the high tide, because I think,
Well, then it's, you know, in order to protect those areas, you have to have some sort of barrier that prevents the water coming in.
Yeah.
But on the flip side, that prevents the water from going out.
Yeah.
So then you have this interior drainage study, which becomes very volumetric as to, you know, how much volume of water do we need to get out during a high tide cycle, as it's not going to be able to drain by gravity.
like the January 5th event is like the highest it's been. I live at the Cove Elementary School area, and that was like, wow, that's exciting. I mean, but it's a 2-3 hour duration at the
Right.
most, right? And then it, you know, we get a little pump station and chugs along and it, you know, evacuates the water. So, but even just the last full moon, the tides were big. I was surprised actually how big they were. Yeah. So, you know, it's not just storm events. It's not just king tides, you know, the high tides as well. So.
Any comments? Chris, I wonder, on the Paradise Tide Gate, which has been repaired and is functional now, so that'll be open in the summer. Does it shut off if we have an unexpectedly high tide, or does it will it close at a certain tide level?
Yeah, it basically it has a transducer that can tell when the tide's coming in, and then that triggers it to shut.
Okay,
And then when the tide goes down, it opens up again, water comes out.
yeah,
So that's generally how we control the water during the summer.
yeah. So that'll allow that area back in there to flush and be better for the environment, and people will be happier with it and everything.
Yeah.
And that'll take some of the pressure off the San Clemente pump station.
Yeah, so that we don't run the pumps very often in the summer, which is nice, because
Yeah.
it helps it last longer. And
Yeah.
also next summer when we have to shut it down, we're hoping that we're using the gate, we'll be able to get through the summer.
Okay.
Yeah.
The San Clemente pump station has been our nemesis. We've just poured a whole bunch of money into that. I've always been concerned about the box culvert outfall into San Clemente Creek. And it has the flat grate on it that keeps cracking and breaking loose. It seems like, to me, there's a lot of resistance to pumping, especially when trash gets trapped in there. And that maybe having more of a cage with elevated grates on the four sides and then a flat grate on the top would decrease some of the resistance, maybe take some of the pressure off the pumps and the pipes.
Mhm. Yeah, we could definitely look into that. The biggest thing was actually, which is part of the fix we're doing now, is that the inside liner was coming off in huge chunks, and they're like flat sheets that would get caught in the grate and create incredible pressure. And so that's what broke it several times. So now there's no liner left. So at least, I mean, what comes through, there's some trash and some sticks and stuff, but that doesn't really get caught too much as far as like on the bottom of the grate. So, but yeah, that could be improved.
Chris, Ben, are you available to comment on that? So we've also hired Schaff and Wheeler to do the design for that project. So.
There he is.
Yeah, hi. Yeah, no, I haven't seen a lot of debris on that rack, but it is, it's definitely undersized for what you would typically design like a trash rack for. However, the pump station does have a trash rack upstream of the pumps as well. So, I think if you are getting binding of, vegetation material on that outfall structure, then you might want to take a look at it. But if not, then the box itself is big enough, but the grate openings are fairly small. So, there is a potential for that. The biggest issues we were having with the pipe was just basically the pipe. We had some pipe joints that were failing. All the welded steel pipe near the pump station is completely corroded and had some failed flanges there. And that's all going to be addressed with the new discharge header at the pump station that's out to bid right now. So.
Looking forward to the final master plan. Thank you.
This grate looks very similar to the one that's just on Lucky Drive, right? That kind of bubbled up.
Yeah,
Okay.
the Black Hill Lagoon, yeah, there.
Really like that.
Yeah, it's the exact same design. So yeah.
Okay, any final questions?
Thank you so much.
Thank you.
Thank you, Robin.
Thanks, John.
Yeah.
Thanks, Ben.
Thanks, everyone. Have a good night.
The Marina Village firm, you're not involved with that, but Chris is going to tell us about it.
I think,
That was actually folded into this discussion. It was really the update that we've put $200,000 in the proposed budget, which will go for its second reading later this month. And that'll go to fund additional design work or preliminary engineering on top of, what was invested back in, I think it was 2017.
Okay, and so this is going to focus on the whole berm or the low spots.
That'll be one of the early things that I think we want to accomplish is really confirming those vulnerable areas just through looking at the available LiDAR data and GIS info. It's not just the berm on the north side. There's at least, a few homes that we believe are low spots and potentially more. So that'll be an early exercise to analyze.
The homes that that you're saying are low, are those the ones that, in Marina Village or, Mariner Cove 5?
I don't know that by name, but they're closer to Paradise Drive, and the homes are on Harbor, so it's actually fairly close to the Harbor and Paradise Drive intersection.
So this is the berm that's behind Harbor, not
Yeah.
just North Berm.
That's correct.
Good. Well, it needs to be looked at.
So there you keep asking about loans of.
Yeah.
Yeah, that'll be the big question. Is the one on the north side was much easier to access and fix. And it's not in private property, so. So hopefully we'll start that in the next fiscal year.
Okay. Very good. Town flood protection website?
Yep. Anything else?
Okay.
Thank you. Okay, so this was a request in the previous meeting. We were discussing the CRS and the flood mailer, and came up that it would be a good idea to have a flood protection webpage. And as it turns out, we already have one, but I just wasn't aware of it. So there, we have a webpage that has a copy of the 2020 flood mailer and a bunch of FEMA links, and then it has links to other town websites on all our lagoons and flood control. So I can open up really quick. Just
Before we jump into this, I do want to go back, and I don't think we pulled public comment on the previous item. I think it's proper that we do that.
Oh, okay.
Any evidence of anybody with a raised hand?
Oh, yeah. Ramon is attending and has his hands up, so.
Go ahead, Ron.
Hello, can you hear me?
Yeah.
Yes.
Okay. Well, thank you for getting this open to the public. Somehow I've been joining a couple of times to this board, but I don't know how to join as a member and rather as a public. But yeah, I had a raised hand because I had a question for the questions and comment for the moderator. So unfortunately, she left. So maybe the questions can be relayed by RJ. So one of them was related to pulling data from all the logs. We have to be mindful of the datum that they refer to, because some of them, if they're old enough, refer to NGBD 29, and some the newer ones maybe NABD 88. So having a common, ensuring that we're using the same datum for elevation, it's paramount to making sure that all the historic data is translated accurately into the model. I'm sure they did that, but it was just a comment because it's common to have different datums, and it's something that needs to be checked. Another question that I had for the model was, how did they model the ponds for infiltration, exfiltration? I don't know if they assumed that these were perfectly impermeable, or if there was some sort of inflow and outflow from the ponds vis-a-vis the surrounded phreatic surface. Do you know if how this was modeled?
So Ramon, I'll explain. Unfortunately, as of March, you're only able to comment as a public comment. So you've got a minute and a half left, and then Ben sounds like it's here. He can answer any of your questions. But yeah, that's a new change in the Brown Act emergency. They removed the emergency thing. So if you want another minute and a half, please by all means share, and we can try and answer questions.
I don't need another minute and a half. I was just had some sort of questions and comments that unfortunately I couldn't post before, so I'm relaying them to you so you can follow through on them afterwards. I don't need the answer now. And then the final question was about the calibration of the model, what sort of data they had to calibrate the model and with reality. I don't need answers for any of these. They were just questions for them to, if they had considered or to consider for their final version. Or if you know.
Yeah, I can probably help respond to those. Thanks for the comments, Ramon. Yeah, in regards to the elevation datum, yeah, we'll definitely be taking a close look at that. Yeah, we've had a lot of issues. A lot of times the old historical elevation data doesn't necessarily list the elevation datum that's used. So there definitely be anytime that we're using older data, we make sure that we understand what the datum is and make sure we get the conversion right. And then in regards to the pond INI, typically the way those ponds are being operated prior to a storm is that they would be lowered to a certain elevation, and we would have a certain amount of storage available during that storm itself. So taking into account INI, infiltration into the ground within that pond surface during the storm, I believe we're neglecting that. I can confirm that though. Typically during that storm, you're not going to have a whole lot of water infiltrating into the ground, especially since those ponds typically are held at a higher elevation and the ground is fully saturated. And then typically for model calibration, as Robin mentioned in her presentation, typically we would calibrate the rainfall. And the way we do that is we look at local stream gauges. And so we produce a rainfall that would be reflected in the runoff within a channel. So we look at all the historical data in the area, pick stream gauges that have a lot of historical data, and then we calibrate it to that. So that's kind of a general process of how we would calibrate the model.
Okay, thank you for the answers. I appreciate it. I don't know if regarding the data for calibration, if the town captures and can share pond elevation, for instance, or if we have any other way to measure stormwater flow within major mains, or if we don't have such capabilities. But anyway, thank you very much. That's all I had.
Great.
Okay, any more, did that create any questions or further comments from the flood board? Again, as a reminder, as of March of this year, if you are unable to attend in person as a board member, you can by all means attend as a member of the public, but not in the same capacity that you otherwise would be if you were in person. Okay.
Anything further on the webpage?
Yes. Let me just turn to the webpage really quick. Just take a quick look at it. Okay, so this is the flood protection webpage I was discussing earlier. As I mentioned, we have the old newsletter up there that is more in depth and has a lot of information about Corte Madera. We have flood hazard area maps, a bunch of information about the National Flood Insurance Program and CRS. It shows that we're class 6, which is a 20% savings on insurance rates. And then there's links to lagoon and waterway maintenance and the town's floodplain ordinance. And down below, lots of FEMA links of everything flooding, and then a link to NOAA on the tide information. So a lot of useful information on there. So I recommend just taking a look, and if you think we should add anything, let me know and we can review it. Because it's always good to improve.
So this could be important because FEMA has restricted what we can say in the newsletter goes out to just what they want. So we can put things that are really more relevant to Corte Madera.
Exactly, yeah. And I think while they restricted the newsletter that we just sent it out to, I think, everyone in town, we still can add a link to that webpage. So if we update it, we have more information.
Yeah, we had a blank page, so we did provide many of those links to the local useful information that we previously passed around in the past.
So that wraps up that topic. Any questions on that one? Okay, just double check that.
Sea level rise links.
Yeah.
Ramon has his hand raised. Oh, he put it down, so maybe that was left.
I wasn't sure if that was from before.
Okay.
Oh, yeah, he has his hand up. So, Ramon, you can unmute. And speak.
I apologize. I should have lowered the hand before. My bad.
Oh, no problem. Okay, so we can.
Anything on sea level rise links, or is that just going to be part of the web page?
No, so this is a different topic. I can talk about now. So this was another request from the previous meeting that the town should have a webpage about sea level rise, flooding, subsidence, and groundwater. So we haven't started putting it together yet, but I did some research on, what the county has and other agencies. And so that both the county and the county flood district have pretty comprehensive websites with a ton of information about current adaptation projects, workshops that have been done and they have videos of, they have media reports, news reports on it. So a lot of really useful information there. And then our own climate adaptation assessment has a ton of resources linked on our website that goes over all the local, state, and the federal reports on sea level rise. So a lot of good information there. So I think our thought is that we should link those web pages. We'll create a new sea level rise web page and link those, and then we can add some more information on there, like links to the tide information and other things like that. So if anyone has recommendations on what should be included, just let me know.
Yeah, that's great. I've been pushing for having a common understanding so the public would understand it. And at a bare minimum, there's really only two inputs for actual design elevations that are absolutely necessary. And one is which tide gauge are we using, what the datum is.
Mhm.
And so I know we have a couple of good choices around here. And the other is what is our source for sea level rise future predictions? And I'm sure that's California report is on there.
Yeah.
But if you have those two things, you can get to an actual number and not just ideas about projects. So if those are prominent, and then you have all this other stuff, that'll be great.
Yeah.
I do have a kind of a general question. I know in some of the counties, they have like a bayshore resilience kind of group, we'll call it, right? It's really looking at projects. Do you know if Marin County have anything that is more countywide? I know there's lots of individual places, right, where projects are being developed. Have you heard of anything like that?
As far as sorry, RJ, go
I want to speak to that. So there's no JPA, Joint Powers Authority, for that, such as like what you see with the Marine Wildfire Authority. But there is a Bay Wave Steering Committee that meets. They've changed it recently to potentially every month. Sometimes they get skipped, but it's really a collection of elected officials along with several staff members, and then from Corte Madera, myself and our climate action coordinator sit on that. So we're all, sharing notes, trying to help each other out, guide, countywide strategies to, adapt to future sea level rise.
Yeah.
The North Bay Watershed Association, which meets monthly, and it's North Bay. I mean, a lot of their topics relate to just potable water as well as sanitary treatment, but they'll often have topics about restoration or in relationship to sea level rise. So that might be a good link to put on there for people to be aware of.
Sure.
Yeah, and I don't know if it's appropriate for this webpage, but for all of us in this group, there's a Tam Valley Sea Level Rise group. And so I'm a part of that, just to kind of listen in. But they deal a lot with what's going on, especially at the Manzanita parking lot underneath the freeway that gets flooded. And it's very interesting to listen to them. They're pretty advanced and they've been working together for a while about how they interact with county authorities and state authorities and town authorities. And we could learn a lot about how those groups get along or don't get along and how they get things done.
Yeah.
So they have flooding issues on Coyote Creek also, I believe, that they are trying to address.
Yeah, and it's probably the biggest mess in Marin is that the tidal inundation in that area is probably worse than anywhere in Marin. So they probably have to fix it first.
Yeah.
We'll see what they do and how they do it sort of permit wise. And
One of the proposals that I'd seen early on from the county for Coyote Creek was a tide gate at Coyote Creek.
a gauge, like a tide gate.
Tide gate, yeah.
Yeah, I've seen the water right to the top of that levee, like houses right behind it, so,
Yeah.
yeah.
And I don't know if this is the right place to just mention it, but I have reached out to Howard Bonds, who is like the county stormwater coordinator, but he also coordinates the meeting of the regulatory agencies when you need to get like Corps of Engineers 404 permits and all of the permits that you have to, get to do any kind of project in the floodplain. And so I'm reaching out as me personally, as a homeowner on, the Golden Pine side of the world, just to kind of get understanding of, what kinds of things are people doing? Because I think, we talked about a berm because of the inundation from the tide. And I'm just trying to get some ideas. So, try to figure out whether there's a way, whether it's briefing here or whether it's briefing to the neighbors, honestly. I do this and it's hard. So.
Thanks for doing it.
Yeah. So I'm just trying to, see if we can find a direction that makes sense, even, and it sounds like the work that Chaplain Wheeler's doing, 2D modeling, will help us understand the nature of the problem better, right? And what can you do, right? I get that because of subsidence, some of the storm drains and the curbs are lower, so that's why the little slot drains help, but those only help in certain circumstances, right? And so, it's a broader challenge, but I have started ball of at least trying to get out in front of it a little bit and understand, as personally, if we have to do something, what would that look like? And, we've had actually a lot of turnover of homes on that stretch.
Yeah.
So that's actually kind of good news, I think, because people are really kind of interested, and we saw that in the last meeting. And so I think, there's an opportunity to kind of get folks engaged on that, and we'll see where we can take this, but I better understand the nature of solutions that they could permit and what the permitting effort is, right, for something like that.
Keep us informed.
I will. That's why I thought I'd bring it up. I sent an email out last week. I haven't heard back. He's on vacation. So it is I can send a link out, but it's basically, there's a permit coordinating group. It includes the Army Corps of Engineers for the 404 permitting. It includes the Regional Water Quality Control Board for the 401 water quality certification. It depends on what it is, but Fish and Wildlife, U.S. Fish and Wildlife Service, NOAA Fisheries, Cal Fish and Wildlife, BCDC, right? They all could, and the county could all have a part to play in permitting something like this.
Yeah.
Notwithstanding in Triangle Marsh being a restoration from, I think, the Nature Conservancy, I think. So it's complicated in that area. So, but if we don't start asking, we'll never know. So I'm starting to ask.
Yeah, good.
That's great.
Yeah, and I was going to say, if you go on the BCDC webpage, they have archives of their hearings, and so a lot of these real life projects are presented and discussed. And so, I wish I had all the time to really drill down, but I am aware of some of them. For instance, recently there was a sewer agency that was really close to the bay, and they, had a hearing about putting a levee with I think it was it was either a coarse beach or a ecotone slope as part of their overall project. So, those things are being discussed regionally and at BCDC amongst other regulatory agencies.
Yeah, there's a lot of that, the ecotone slope and part of water quality. Separate from all this, there is nutrient levels that are being considered tighter for wastewater. And so there's a whole different effort related to that. So, and using kind of some ponds with, you know, ecotone slopes and being able to run the treated wastewater through a levee that can help knock the nutrient load down, like more of a wetlands type thing, an idea, so. So, yeah, there are many struggles, related to, you know, sea level rise.
So it'd also be good to follow the Santa Benicia project to see
Yeah.
how that goes as they try to get that permitted and
Right.
get something.
Yeah, that's more of, if I remember correctly, like, their sheet piling, I think.
Well, they have a berm now, and I know they have to add to it. And I guess I was sheet.
I think it was a sheet pile kind of approach.
Yeah.
So,
Okay,
Okay.
project updates?
Well, it's, Ramon has his hand up. I don't know if it was still from before, but, Ramon, do you have anything to add? It may have just been from before. Okay.
Project updates.
I do not, I apologize again. I don't know why that hand popping up. I am not pushing it, but it's just, I guess I'm doing something.
Technology.
My bad again. I don't know how it happened.
No problem. Okay, so project updates, we have check valve maintenance, new air release valves at High Canal Pump Station, and maintenance project to restore open channels. So, check valve maintenance, there were several storm drains that overflowed in Marina Village in Maricopa during January king tides, and there was no rain going on, so immediately point fingers at water coming through the outlet pipes of the neighborhood. So in spring, our maintenance crews did the spring gate maintenance, and as part of that, they checked the pipes, check valves and outfalls. And so the main issues they found, which is the first one's pretty typical, there's debris caught in some of the check valves, which wouldn't allow them to close, so the water can still get through. The other ones are new. So some of the metal pipes that go out into the bay are heavily corroded. And so there may be a valve at the end, but water is coming right underneath through the pipe. So the valve's not doing anything. And almost all the pipes we found they're concrete right up to the shoreline. And then they use one stick of metal pipe to come out, which is typical because if you use concrete, sometimes it's so heavy that the last stick will fall off and it can collapse the end of it. So they use a lighter pipe, but unfortunately they're all corroding now. And then also in a few cases, the pipe outfalls are completely buried in mud, which is causing issues for both directions, water getting in and water getting out. So these are all things we need to take a look at. And then also we were surprised to find that there's still a handful of culverts in Maricopa that don't have check valves at all. So we may want to consider those locations in the future. So this is a map I just put together quickly. So the blue triangles are all outfall locations, and then the red dots are check valves. So Baja Court was one of the locations we had water overflowing, and that was just because this valve was malfunctioning.
Upper level.
Oh, sorry. This is in Marina Village, right up here.
I think we moved a little picture.
Yeah. Oh, yeah. Unfortunately, I can't do it from here.
Uh-oh.
So yeah, we had Baja Court, we had water coming out. We also had water coming out on the street on Seawolf and Prince Royal. Yeah. So these systems all drain out here, and this does not have a check valve. So water can just freely come into the neighborhood from there. This one should have been protected, but I believe we still had water coming through, so I think that was more of a maintenance problem. And then, I believe Key Largo, of course, also had water come through. That system does not have a check valve on it. So these are all places that we could, improve, if we add check valves to keep the water out.
The Golden Pine, that does have one, right? Well, there's one, that one, yeah.
This north one at 219 does not have one, but I don't think we've had any issues there. I think it's a little bit higher up. And then these two on the right, this one pipe that goes under the sanitary pump station that does have a ductile at the outlet. And then the pump station down here has one that's working, so. So yeah, a handful of spots that aren't protected currently.
What's
So-
a typical cost for something?
So we installed an inline check valve here a few years ago, and I don't remember the exact value. I want to say it was like $10,000 to $12,000. They're pretty pricey, but those ones work pretty well. They basically just fit inside the pipe.
And you don't have to go and muck around and.
Yes.
Out in marsh and all that, right?
Yeah, so that's the biggest issue, like where we're having problems with the ones at the outlets. We can't really do much to maintain them because you're in protected habitat.
Could you do a secondary inline one?
Yeah, that's an option.
Just,
Just-
that's just a,
Just need the budget and
Yeah.
the time to do it, but yeah.
The other thing to consider is the ones that are in line closer to the catch basin. If there's not something also on the outside, they could allow silt to come into the pipe. So then so unfortunately, there's no bulletproof solution.
right.
Okay, so I got some pictures here. So on the left, this is at 113 Golden Pines. You can see that outfall pipe's severely corroded, and it actually used to have a ductile and it's stuck in the mud right there. Yeah, but this one actually had a secondary check valve on the inside. So, I mean, I think obviously it's better with two, but the one should be working normally. And then on the right, that's 219 Golden Pine. You can see the whole top of the pipe's gone just from corrosion. So this left 127 Golden Pine, this one, I don't believe it ever had a check valve, but as you can see, the outfall is corroding away. On the right, this is actually not in Mariners Cove, but it's farther up Paradise, and that the whole bottom of the pipe is just corroded out. So that one's going on our list to repair at some point. I think we're going to try and include a lot of these in the master plan. That's recommended
What's the
repairs.
scope of like you pulling all that metal out and redoing, or is it just the kind of saw?
It depends. I didn't really go out and take a close look, but on the right one, particularly, we might be able to line it. And that way we would have to dig it up because I don't know what's sitting on top of that. There could be a house. I'm not totally sure where that is. So digging it out might be a nightmare, but we've had really good luck with liners before. So
Yeah, because the corrugated metal, right, it just doesn't last. I don't know, you get 10 years out of it?
yeah, but in
A marine
my
environment.
Bay areas, yeah, it's tough. I mean, luckily in town, they actually use concrete pipe in most places. So that's what Robin was talking about earlier. Like a lot of them are still in really good condition. But all these outfalls, unfortunately, are metal. They do make aluminum, which lasts a lot longer, but it's just more expensive. So maybe we'll replace them with
Did
that.
they do HDPE as well?
Mhm. Yeah,
So,
yeah, that's a good option.
Cheap.
Yeah, yeah.
So Chris, the situation at the MCAD sewer pump station and drainage, that was not our typical, sort of inline, on board, flat, check valve. was something different because of just the way that whole system works there. Is that correct?
That one, I don't remember exactly what it is. I think it's a duckbill on the outlet that's behind the pump station. That one actually was in good condition, so.
But the valve may be in good condition, but it's not working to prevent, the water from backflowing. And I don't know whether it just comes around or because that area is settled so much, the box itself is broken up and water's just seeping in, but it doesn't seem to slow the inundation. And then, of course, you get to a certain point, it starts flowing, over and around the pump station there.
Yeah.
But it really doesn't seem to be, working as the way it's supposed to as a check valve. The way it works on the other outfalls when they're maintained correctly.
Okay, that's good to know, because I know it doesn't take much of a tide for the water to start coming over the top, but I didn't realize it's also coming through the storm system, so we can try and take a closer look at that one.
Yeah, I think if we were ever able to have a berm there at some point in the future, that would probably be a spot to actually put a pump station in for the stormwater.
Yeah, that will definitely be required if we ever, levy around it.
Yeah.
So. Okay. Good to know. So I think this is one last one. This is just off of on the other side of the Lucky pump station. This is a pipe that drains some storm drains in there's like apartment complexes across from our courtyard. And we have a flapper valve, but it's hard to see, but you can see straight through the bottom of the pipe. There's a massive hole. So water is just going right underneath and through. And so I think Robin had some pictures of the king tide in their parking lot was flooded. And so it was probably just coming straight through there.
And the flapper valve also sees too, right in the road.
Yeah. I mean, none of the check valves work perfectly. The flappers get stuff stuck in them less, I think.
Oh,
But
then like the duckbill.
yeah, they all have issues, but yeah.
This is that area where the road is really subsided right there.
Just over there, right?
Yeah, exactly. Just right near our courtyard, like before you get to the culverts. Yeah. So that's all I have for that. Just have a lot of projects to do in the future. Fixing all these outfalls.
Well, I think it's pretty good bang for our buck if the check valves will work to put those in to, prevent the ponding and flooding that happens without a rain. I mean, we'll still get it when we have a big rain because it can't drain any place, but the times when it's not raining, it keeps the streets dry and DPW doesn't have to put out flooded signs.
Yeah.
The other thing is that rainwater erodes the asphalt. And I don't know what the cost is of redoing all the roads every 5 years. But on it might be better to just keep the water off of it.
Yeah. I mean, when it sits for days, that's when it starts getting damage.
Questions?
No, I just think it is a priority to kind of get those on the earlier, I guess, part of the CIP, right? They seem like relatively inexpensive and.
And people see the result. You know what happens when these aren't in there, and they really help a lot. You do have to explain to people that
Right, it's not going to work under every circumstance.
Okay.
Just to elaborate on the road kind of comment. So the primary reason that water is kind of the number one, road killer per se is the water then gets into the subgrade, which makes it less structurally sound and causes it to grade faster. And so that's just kind of the main thing to consider when we're looking at roads and in areas where it's wet and have water.
Okay,
Okay, no,
air release valve?
yeah. Okay, this is just a quick one, just a quick update about some work we did, at the High Canal Pump Station. There's 4 pipes and 4 pumps and 4 vacuum air release valves, that were last replaced in 2011. And they didn't fill late last year, and it was every time the pumps kicked on, it was just shooting a geyser up, and they actually have these wood boards over the top, and some of our maintenance guys saw them just getting knocked off because there's so much pressure. So that became definitely an issue. So our maintenance team was able to just order them and replace them in-house, saved us a lot of money because we got some astronomical costs from our usual contractors to replace them. So that was good. And now all 4 pumps are working and it's good. Yeah.
That seems cheap compared to some of the costs for the other pump stations we've had to deal with.
Yeah. Those parts, air release valves especially, are really expensive. So yeah, definitely save some money there.
Question? Maintain open channels.
Okay. So we are trying to initiate a project to start maintaining some of our open channels, and I mean we may actually tie in some of the pipe outfalls as well because I have some pictures, but you can see some of them are just buried in mud. They haven't been dug out in a long time. And then also a lot of the channels are just overgrown and silted in. So it is starting to impact some of the storm systems in a few neighborhoods, particularly Marina Estates, El Camino. We've had water backing up. We just redid the storm system and thought it was going to work perfectly, and then it started to back up again because the water doesn't know where to go in the channel. So the main issue is most of these channels are considered protected waters with sensitive habitat. So we can't just go in and start digging. We have to get, regulatory environmental permits. And so our plan is to request proposals from several environmental consultants and hopefully in the next few months, and then proceed to acquire the permits in order to maintain these channels and outfalls.
The one on El Camino, that drains to the channel behind the shopping center. And
yeah, it runs parallel with El Camino, and then it goes under the road, and then it goes behind Aegis. Actually, I think that's the next slide. Oh yeah. So we are having water backing up over here on El Camino, and this storm system runs under, connects to here. And then this is an open channel all the way over until up here, and then it goes, this is the culvert that goes to, San Clemente Creek. So I've got a few more pictures, but
Is it clogged the whole way now? There used to be a really deep channel. I know because I fell in it as a kid.
oh really?
I caught a lot of garter snakes in it, but it was a deep channel. It's take a lot of soil to fill that thing up.
Yeah, so you probably have good knowledge about it, but it's, I mean, I walked it and it's pretty
It looks like
silted in.
it's not very deep.
Yeah,
I haven't been back there in years, but it didn't used to look like that.
Yeah, this is the very end. It's next to the several schools off El Camino. And so you can see this is the outlet pipe from El Camino, and it's half full of silt and water's not draining out of here. On the right, we're looking the other direction down the channel. You can see it's just completely overgrown and pretty silted in.
And it was always just an earthen channel then?
Yeah, I believe so. And I think our crews used to go back and just weed whack once a year, but now I don't even know if we technically could do that. And I don't know if they've ever really dredged it. So it's just been slowly filling in.
so the picture on the right was behind El Camino.
Yeah. Yeah, this is looking,
Townhouses are up the hill, right?
Yeah.
yeah, this is looking technically north, of Caminos over here on the left.
Yeah, and this is an example where the actual work itself and any engineering would be really simple, but the permitting is going to be a huge challenge. So, and unfortunately, it's probably going to take a while. But we're going to start that process and keep pushing.
Yeah, so top left, this is, the channel goes down, Camino goes underneath the road and pops up the other side. So this is one smaller pipe, you know, you can see it's half full of silt, and it has to kind of fill up a ways before it can go down. This is farther down the channel. You can just see there's a lot of buildup, a lot of like trash and tree debris in here. This is actually a storm drain coming out of Aegis, and it's almost completely full. So that's a little concerning. I don't know if that's all private or if it connects to the town storm drain as well, but there's not a lot of capacity left there. So
Is establishing kind of the grade and the capacity, is that within Chapaloosh though?
on some of our larger, like high canal and low canal that are connected to lagoons, they're looking at that.
But this may not be.
Yeah, I don't think they're looking at this one. These are kind of smaller channels. So the only, so I don't have a picture of it, but if you keep going down to where it goes underneath Paradise and House Creek, that channel is actually still pretty deep. It connects all the way around to San Clemente Pump Station.
Right.
So that it's looking still like it's okay, because I think there's a lot of flow regularly.
Right, they just blast through there.
Yeah, when it's raining, the water's like shooting through and it keeps all the silt moving, but over here it doesn't do that as much, so. That is the issue. Next open channel is right behind Toscalito Tires. So this is Paradise Drive, this is Highway 101. Over here is San Clemente. So this there's a culvert that goes under the freeway and drains a lot of Meadow Sweet and Casa Buena. It's a pretty good sized watershed over there that drains into it. It goes underground to here, and then it comes up and goes through an open channel just in this little section, and then goes back under. So here's some pictures. So this is where there's a pipe somewhere down there. The water has to build up all the way up here and then flow through this. I don't know if this was ever down to where the outlet pipe was, but it seems like it's very filled in. On the right, this is looking the other direction. It's pretty overgrown, pretty silted in. And then
That hasn't actually caused any flooding problems over there, has it? According to Toscalito, when I've asked them about it.
yeah, I don't think so. We haven't really seen any flooding. Surprisingly, because it seems a little concerning when you look at it, but
And you mentioned the large watershed across the freeway, and I recall it kept flooding over there by Tesla.
Yeah.
yeah,
You guys enlarged one of the pipes and you didn't know what was going to happen downstream, but you said, let's enlarge it. And when it's flowing more, let's see what it does in this channel. But it sounds like I think it should be cleaned out, but it sounds like it's not causing
Functioning okay.
horrendous floods.
yeah, I don't believe it's caused any issues so far. It's just, it seems like it's, we should have maintained it a while ago. So it just keeps filling in.
Can it be piped, or should it be piped, or?
We could definitely consider it. The one issue I can see is I think the pipe that outfalls, just to the left here, looks like it's lower than the one that it goes into down here. So it has to build up and flow through this channel and then get into.
It's almost like a little detention area.
Yeah.
And then you run off, it's gonna end up there anyway.
Yeah,
As like a little storage.
yeah, exactly. So I believe Chapman is going to look at this, but while we're doing this project, we might as well try and get this
Yeah, like
permitted.
capture anything that you could ever possibly want to maintain, right?
Exactly,
Yeah.
So, because it'd be nice to just take care of these all at the same time.
Yeah, and on the Tesla side, the pipe that goes under the freeway, that pipe remains the same size, but we did make some improvements to capture and through inlets and an additional catch basin to help get some of that water freed up, but again, didn't increase the pipe that goes underneath the freeway. So
Yeah, there was a weird situation because there was an 18-inch pipe that was downsized to a 12-inch, and then it dumped into the pipe under the freeway. So we just enlarged it to 18 all the way. So it seemed to help a little bit. So now we're looking at the Marina Village, just north of Marina Village. There's some drainage channels that were existing. This drains the area west of Marina Village. That's adjacent to San Clemente Drive. And then there's some outfalls from, this is Echo, and then this is Harbor. So there used to be deeper channels where the water could reach the detention basin, and then it would be pumped out. Fortunately, it's all been silted in and overgrown just like everywhere else. So here, a little pond is formed next to Marina Village because the water can't make it out anymore. There's no really defined channel. And then these two on the right are the two outfalls we're looking at from above. You can't even see the pipe anymore. It's just completely covered in vegetation, and then there's just no defined channel at all. So the water has to really build up to get out, and so that's backing up into the whole storm system. So if you got a really big storm, that would definitely impact the capacity.
You were saying that there was some flooding in Marina Village with the storms this last year. Was that the cause of it?
No, that was the only issue we had was on Baja Court. That was from the check valve not working.
Okay.
Yeah, that it wasn't even raining then. It was just the
And that's
tide.
River 5.
Or yeah, is that well? It is in Marina Village, but is that
Right, it's the Maricopa 5, which overall is higher, and it was they had more fill brought in when they did that. Marina Village is really protected by the berm on the north, as well as the berm along San Clemente Creek.
yeah, exactly.
Yeah.
And Baja Court is a low spot too. It's like lower than the surrounding neighborhood.
Yeah. Well, the Baja Court has that problem there, and it relates to the drainage off channel going into San Clemente Creek. Where you said the check valve didn't seem to be working.
Mm-hmm.
Yeah.
So now we're looking at some outfalls. This is on the left near Westward Drive, just off Paradise. So you can see pipes completely underwater. Just like everywhere else, there used to be a channel here and it would drain. Now it's silted in. It has to build up above this elevation to get out. So it just makes it not work as well and harder to maintain because we can never really see the pipe. On the right, this is at 137 YOLO. There is a flapper down there somewhere, but it's just covered in mud and underwater. And so this is tough because you can just see that's basically wetlands around it. So it's going to be really hard to get permission to dig that out.
Well, that would be where you'd want to put the check valve on, in the sidewalk in the manhole, and just leave that alone.
You could, but that's not going to help the fact
Drain
that
that
it's
area.
under mud.
Yeah. Well, I guess that area is higher because I don't believe they've experienced any tidal flooding.
Yeah, I don't think so either. But I think even though this is kind of buried in mud, that flapper is still working for the most part. So Yeah, we haven't seen any water going in there, I don't think.
This is in April this year.
Yeah.
So if there was, pressure, if, a hose under great pressure was put in at the, manhole, the catch basin, would that tend to clear out some of the mud that's, that's in the pipe that potentially you could do that, without causing environmental impact because you're not doing anything in the wetlands?
Well, that's probably a little bit of a gray area, but I think if you're pushing pressurized water and like debris out of the outfall, it might be.
I
still an
don't know that
impact.
you can totally, because you really, then you have kind of a big hole maybe at the end of the pipe, but you're still gotta establish a channel to get the water out of there, right? That's the.
Yeah, yeah.
So you've kind of evacuated the pipe.
Well, this is just at very low tide right here. It's an extreme low tide.
Yeah,
Yeah, it was definitely low tide when it looked, but
you
I
should
mean,
basically hydraulically mine your way out of
Yeah.
it.
Yeah, I mean, they're not having,
Oh, it is.
flooding now, so rainwater must be draining through there.
yeah, it's making its way out when it gets high enough and the pressure builds up, but
Well, let's build up a little more pressure.
yeah.
Get Roy's sewer service here.
Yeah,
Yeah, you guess you'll have to craft what does maintenance include and how does one accomplish maintenance when you get the environmental consultant on board to do the permit.
yeah, exactly. So here's a few more. This one is at the end of Spindrift. This is at like the lowest tide, so the water never goes below this because channel that drains it is no longer deep enough. Chair Bundy mentioned this one too, because I believe we have water getting through, and apparently there's a check valve in there, but it's inside the pipe, and so it's impossible to maintain when there's water above it. So our crews can't even look in to figure out what type of check valve it is. So if there's any issues with it, we can't maintain it. So that one's problematic. This is 18 channel drive. There's a pipe down there somewhere, but it's just buried in mud. So there's just a few like that, where, I mean, we could go and dig this out, but it's just a temporary solution because the tides will just bring it back.
But the problem with the flooding there was tidal flooding, coming back through, when the check valve was not functioning.
Yeah, this one, it's kind of two separate issues. The check valve wasn't functioning, but that's on the inside, the street side. This is just buried, so it's just restricting flow in both directions.
Yeah.
So,
Well, I mean, it just seems like the problems there are flooding related to really high tides, and the check valve not holding them.
yeah,
And interestingly, because there's been some drainage created at the end of channel, the water will come up through there and then go north out the drainage at the end of channel out in that sort of wetland area that Marina Village drains into also.
It's
okay,
kind of a different way to get out.
Yeah,
right?
yeah.
yeah. So it's eventually getting pumped out. This is the channel drive floodgate. The left is looking inside it. The gate is down there somewhere. And then the right is the outfall, just completely covered in mud. We hadn't used this gate in a few years, and so obviously it's a little bit neglected, but this is it. You would use this gate to let water go into the Marina Village detention basin. So right now it's just not functioning at all. So
And it's in the closed position right now? Okay.
yes, I believe so.
Okay.
So now there is some water that gets through there, but it's really just a trickle because you can see a little bit of a channel going around the door side of that detention basin, down to the culvert that takes it to the actual detention basin.
I was told they used to leave it just a little bit open during the summer just to get some water into the detention basin so it doesn't get smelly or too much algae, but seeing this, I'm surprised anything gets through there.
No, there hasn't been very much that's gotten through for a long time. It's, it's no longer wetlands, it's mostly invasive species, but there is this tiny, sort of rivulet along the north side.
Mhm. Yeah, so that one needs some attention. And then this low canal, we're not proposing to include it in the project, but we've definitely noticed that it could use some attention as well. So it's hard to see, but the pipes that come out from under Tamalpais are completely submerged, and if this was maybe 3 or 4 feet deeper, it would be able to flow out freely, but right now it has to build up to get over. Looking the other direction, you can see there's just not a lot of elevation between the park and the channel. And I'm sure Chaplain Wheeler will, they already did the drone survey, so they have that data and they'll be able to take a look. This is just looking a little bit right. This is a gate that drains a lot of Madera gardens, and this is as low as the water goes, so that flapper doesn't work that well. So it just really needs to be dredged out at some point, but that's kind of a larger endeavor than we're looking to do as part of this project. So that's all I have.
We showed kind of a lot of aged infrastructure deficiencies and really it's some eye-opening stuff. Just what we looked at feels like a big expense, upwards of $5+ million, unfortunately. So I think there might be certain segments that we can say, yeah, this makes sense to continue draining using this system, and let's do the permits. But then also there's going to be, I think, at least half the ones I just saw, there is some, I would want further analysis by, Chaplain Wheeler or someone else to say, yeah, no, this is worth the investment to reestablish this system, as opposed to potentially draining it through a new system that's potentially going to give us more life and more cost effective. So, or maybe even some of those gates are, obsolete and aren't needed. So I think definitely more analysis. I mean, the amount of silt and aggradation in a lot of those areas will go for thousands of feet before you actually get to the bay. So, anything you do within 100 feet of the outfall doesn't matter, because you'd have to go another 1,000 feet and take out another 1,000 yards of material before you can actually get it to drain by gravity. And at that point, it might just aggrade over the next 5 or 10 years, and you're back in the same spot. So definitely some tricky stuff, and stuff we have to try and come up with some reasonable solutions.
One of the problems with being able to work on some of these things is that RJ had me go out and try to determine the depth of the water at the mouth of San Clemente Creek. And there's such a buildup of mud out there that water gets trapped behind that. And so the actual tide that you sort of look at in my backyard never goes lower than, I think, around 2 feet, just because of that buildup. Out there, you can have a negative tide, but, it only goes down to a certain level. And so then that, creates more problems and probably contributes to all the sediment that comes out and covers up the end of these pipes.
Mm-hmm. Yeah, I think probably one reason is now we're directing all that flow through the pump station. Well, I guess it still ends up in the same place, but so yeah, actually I don't know why I built them there.
Yeah, I think that's just the nature.
Yeah.
That's what's happening.
Yeah, at a certain point, a lot of these facilities won't function via gravity, and you'll have to switch to pump stations. So that's, I think, really the most critical decision, and that we need to analyze before we throw millions of dollars at some of these. And we're hoping that Schockmuller can really guide us in some of those decisions.
Yeah, it seems like you might want some or all of them to be adaptable, where if they're gravity drained now, there's something that would not have to be completely replaced to add an inline pump station to it later. I don't know if sea level is going to rise that quickly, but you would probably in 100 years, they're all going to be pumped basically.
Yeah, yeah, it'd be nice if we could tie them all together too and not have so many pump stations going on in the neighborhood.
So I think looking at long-term solutions to sea level rise and flooding and the idea of a tide gate at San Clemente Creek made a lot of sense to me, because you wouldn't have to put so many pump stations in. You just have that one tide gate that's there, and it would be drained out prior to rain, so that the gravity can continue to work. I don't know if there's a sense that everybody's going to recognize how big the problem is throughout any low-lying areas in California or any place, and whether some of the environmental concerns will be lessened for small projects like these little drainage ways behind homes and things like that, that it may be a little bit easier to do some dredging or some mitigation, on something like that, as opposed to, trying to, fill wetlands or something like that.
Yeah.
Well, and I think that's the kind of point with my bringing this, just a little golden hind problem, is that it can't be the only one, in the Bay Area, much less the rest of the state, right? And so, streamlining permitting for smaller projects is, has got to be part of the conversation to mitigate kind of the climate impacts, right? I mean, I just can't see us continuing down a 18-month permit cycle to do what I would call a relatively small project. So, I mean, that's probably the point I'll bring up, but it may not even be, these are all individual agencies acting, right? And so it may be legislative actually, is that, when push comes to shove, there's a lot of study being done now, right? Oh, we have all these problems, everybody's trying to get a handle on what it is and what the solutions, but it may end up being, we're talking to David Conley, right? And just saying, hey, we have a broader problem here in the county and statewide, which is that are there any, streamlined permitting, which may be difficult because of Clean Water Act restrictions, but, so we try to be creative, but if you follow these kinds of guidelines, right? And so anyway, I think we're all going to be looking for that, right?
Yeah, it'd be nice to see us going the other direction now.
Yeah, I mean, unfortunately, these regulatory processes are the foundation are some of these acts by state or Congress, Port Cologne Water Quality Control Act. So I mean, even if there were people that wanted to make these more practical, ultimately you would need to amend those acts in some way.
That's one thing in legislative action, right? Act of Congress stuff.
So Chris, on the open channels, I know that the drainage area to the east of Harbor, between Harbor and Mariner Cove 5, Baja Court, there's a drainage area back through there that I guess has got just a lot of growth of weeds and grasses and everything. Is that something that can be just maintained with weed whacker?
I'm trying to picture.
I don't think we're informed to make that comment. Chris, we're not qualified. We can't go there.
Okay, yeah. I mean, I think you need to get the biologist to make that determination. So it's hard to say.
Okay. All right. Any final questions or wrap up or thoughts for future agenda items?
Just when's the next meeting? Look at my calendar.
Should be, this is June, so August. Is the next one.
In August, is it the second?
Um,
Monday?
Second Monday of even months is what
Okay.
are potentially scheduled.
Any thoughts on agenda items? Will there be potentially an update on the storm drain master plan, or is we gonna wait for the final rollout of that?
we can provide another small update. I don't know if how much, new material it'll be. I think last I heard, the draft plan should be coming in December. So,
Off the
At
top of
that
my
time.
head, I think we have Chapman Wheeler scoped for 2 presentations to flood board, and so I would rather save that, kind of toward the tail end. If that's incorrect and we have 3, then obviously we would do another check-in point, but Chris or myself or others can provide an update on kind of where they are if we do not have that scoped
Okay,
in person.
One other thing might be, I think I have like 2 graph slides that I made. They're basically statistics of tide variations over a year, and I think they would be very interesting for us to look at as a group. I can send them to you and RJ and make sure you understand what I'm trying to get across, but it's basically, it shows predicted tides versus actual tides and the reasons for those the deviation, how much bigger your tides can get based on storms and low pressure systems. But it's interesting because it shows the tail of your annual high tides. And like, I think we're going to have to figure out how the town is going to take those tails into account. Like, are we going to protect ourselves against all of those as part of them? But I think it'd be interesting for all of us to see some of those tide graphs and see the kind of magnitude of variation from predicted tides. I could just send those, I think it's like 2 slides.
Was that like the January 5th? That was one.
No,
of that.
I took a heavy rainfall year from several years ago and just
Okay.
downloaded all the 6-minute data and then
Okay.
sorted it. And you can see, it should be in a line basically. But instead there's a tail at the low end from high pressure systems in the summer and a tail at the high end from low pressure systems in the winter. But if you design to the linear, you're going to miss all the storms and it adds up to 30 days a year basically.
Mhm.
So it's just kind of a matter of how much extra you need on top of your predicted tide going into the future. And it's just interesting to think, it's going to add a foot or 2 to your design element at some point.
yeah. I know they built a little bit of that into the wave run up, but it'd be interesting to see like actual recorded data. So.
Yeah.
Yeah. Well, I know that the January 5th was a kind of an extraordinary high tide.
Yeah, I could look up that data again.
Yeah, because I don't know if you were here, but we did a quick survey at the last meeting and I think the Richmond gauge is the one that you guys were using. I looked at the Golden Gate, but it was
Yeah, I was using
like
Richmond. for that, but-
1.5 feet. There's like 1.5 feet over prediction for
Yeah.
that day, and it was like a 6.2 prediction.
That happens almost every year.
So,
That's the interesting thing is 1.5 feet is normal for every single year, basically.
Yeah.
yeah, no, that sounds good information. Okay. Adjourned.